Okay, guys, so we're going to be looking at reflections today. Reflections are super duper easy, but just make sure that you are taking your notes and following along. If you get behind, you can always pause and rewind and rewatch if you miss part of it. Also, you may hear my dogs in the background. They're living their best life, so sorry if it distracts you. So the first thing that we're going to look at is reflecting over the x-axis. So first, if we identify our x-axis, that is what we're going to be flipping over. And if you notice, if I were to flip that x over on top of itself, it would lay perfectly on itself. So when we reflect over the x-axis, we're just flipping over from up here, and then we're just going to flip it down here. So if my A is currently at 2, 3, I know that it is 2 spaces away from my x-axis, so I want to make sure that it is now 2 spaces down here away from my x-axis. And so my A prime is going to be at 2, -3. Now, when we reflect over the x-axis, we keep our x coordinate the same and use the opposite y coordinate. So if you notice here, my x value stayed the same, but I took the opposite of my y coordinate. So my x's, the 2 stayed the same, but I took the opposite of my y coordinate. So if we want to look at the rule for that, if we kind of look at the where we started out with, we started out with 2, 3, and that transformed to 2, -3. So how we would write that rule is we would have x, y, and we would keep our x the same and take the opposite of our y. So if we're looking at reflecting over the y-axis, here is my y-axis. Again, if I was to cut that down where the y-axis would be, I could take this y here and just flip it over and it would lay perfectly on top of there. So I am going to, if I have my original B here, B is currently at -2, 4. So I know that it is 2 away from my x-axis, so I want it to be 2 away over here. So I'm going to have it as +2, 4. That's where my B prime would be at. So when I reflect over my y-axis, I bet you can't guess it, but we're going to keep our y coordinate the same and use the opposite x coordinate. So if you notice here, my y value stayed the same this time, but I went from -2 to +2, so I took the opposite of my x value. So if I want to represent that kind of in the rule, I started out at -2, 4, and I ended up at +2, 4, or I had my x and y value, and I took the opposite of my x and I kept my y value. So that's kind of what my rule looks like. So notice up here when I reflected over my x-axis, my x stayed the same and I took the opposite of my y. When I reflected over my y-axis, I took the opposite of my x and my y stayed the same this time. So if we're going to kind of look at the next part of the notes here, we know a reflection flips a figure over the line of reflection in order to create a mirror image. Each reflected point of the figure should be the same distance from the line of reflection on the opposite side, just like I had kind of showed you up there at the top. So if we want to look at the line of reflection on these, notice how that smiley face flipped over and it mirrored. So if we kind of think back to dilations and translations, our shapes with dilations, it got bigger, but it stayed sitting the same way. With translations, my shape just slid over and it stayed sitting the same way. This time with reflections, notice how my shape is flipping over, and so its orientation, even though it didn't turn a different direction, it is flipped over, so the orientation kind of changed with it. Okay, so on this first one, my line of reflection would be your x-axis, which means if I'm reflecting over my x-axis, my x value would stay the same. On this one, I'm reflecting over my y-axis, which in my rule, my y value would stay the same. So if I want to go and graph these ordered pairs, I'm going to go and graph each one. So on here, it wants me to reflect over the y-axis. So I'm going to flip over this axis here, and I'm going to count each point. So notice how W is 2 away from my y-axis. I want it to then be 2 away on this side. So I would have W prime. X is 7 away. 1, 2, 3, 4, 5, 6, 7. So it's going to be 1, 2, 3, 4, 5, 6, 7. That's going to be X prime. And then Y is 2 away. So I'm going to have my Y here, Y prime. And then I have my shape. And notice how it completely flipped over and mirrored itself. So my new ordered pairs, W prime is going to be at -2, 6. X prime is going to be at -7, 4. And Y prime is going to be at -2, 2. Notice how I started out with my X values. They were all positive. And now all my X values are the opposite of what I started with. Whereas my Y values were all positive and they stayed exactly the same. So if I want to look at the pattern that happened, I took the opposite of the X value and kept the Y value the same. So my rule algebraically, I would have XY transforms to, I took the opposite of my X value and I kept my Y the same because, again, I went over the Y axis, so my Y stays the same. Whichever axis I flip over is the ordered pair that stays the same. So if I want to look at reflecting over the x-axis, here's my x-axis, and I notice D is 2 away from my x-axis, so D prime is going to be 2 away. F is -7 away, so F is going to be 7 away up here. And E is also 7 away, so E prime is going to be 7 away up here. And I go and draw my shape. And you can see the mirror image where it flipped over. So it started here. You notice how D's right here. It just flipped right there. F just flipped up there. E flipped up there. And I basically just took it and flipped it over. So on this one with me reflecting over my x-axis, I'm going to write my ordered pairs. I have D prime is at 2, 2. E prime is now at 7, 7. And F prime is at 2, 7. Notice this time, my X values stayed the same, but I took the opposite of my Y values. So X value stayed the same, took opposite of the Y value. So if I were to write my rule, I would have XY transforms to X stayed the same, took the opposite of my Y. And notice, again, I reflected over the x-axis, my X stayed the same. So let's look at this one here. I'm going to let you try this one on your own. You're basically going to flip over your x-axis first. So for 3, you're reflecting over your x-axis, and then for 4, your shape is gonna end up over here for your x-axis. I got that backwards. Rewind. So for 3, you're going to reflect over your y-axis, so your shape should end up over here. Then for 4, you're reflecting over your x-axis. So you're reflecting here and your shape should end up down here. So you're kind of doing two reflections in one problem. But I just wanted to look, I want you to try that one here in a minute, but let's look at 5 and 6. So Bella thinks that the transformation below represents a translation. Is she correct? Why or why not? So remember with a translation, our translations slide. So if it would have gone this direction, my eye point would have slid over here, and this is where my eye would have been. So notice how that actually isn't a translation. It really, what ended up really happening is here was their line of reflection, and it picked up that eye and just flipped it over right there. So really in this situation, there's no way that this was a translation. So no, it had to be a reflection. And then a couple of things I want you to think just for a second about the similarities and differences between translations and reflections. So we've dealt with dilations, we've dealt with translations, and now we're looking at reflections. So something that is similar about them is that the pre-image and the image are the exact same size, right? They don't change in size or shape. So both create an image that is congruent to the pre-image. Then if we think about differences, when we were talking about orientation, and I kind of just brought this up a second ago whenever we were looking at the picture, we know that with translations keep the shape sitting the same way, right? So the difference is that a translation preserves orientation. Remember, it stays sitting the same way. That's what orientation means. And then a reflection does not. So what you're going to do on here is you are basically going to take your pre-image and you are going to use kind of like what we did talking about with the rule for our x-axis, and you're going to do that. Then you're going to take your pre-image again and reflect over your y-axis. So for example, my pre-image is 6, 8. When I reflect over my x-axis, you should remember that your x stays the same and you take the opposite of your y. So my x is going to stay the same, so I'm going to have 6. The opposite of 8 would be -8. When I reflect over my y-axis, remember I take the opposite of my x and my y stays the same. So in this case, I'm going to take the opposite of 6 and keep 8 the same. So what you should do is finish up practicing these next problems. If you finish that, then you can practice on IXL.